Hi, let's talk a little bit about Ohm's law. So we've already talked about voltage. We understand that voltage is related to the potential energy at various points in the circuit. We understand that current is the flow of charge between one point in the circuit and another point. But it turns out that there's a category of elements in our circuits called resistors. And resistors are going to be characterized by a linear relationship between voltage and current. A linear relationship is just about the simplest and best kind of relationship that we can have when we're talking about a circuit analysis. And so we're going to really focus a lot of our attention on the Ohm's law. You can see here Ohm's law, V equals I times R. That's going to allow us to be able to easily calculate one of those quantities if we're given the other two. Anytime that you see a resistor in your circuit, you should be happy because it's going to be very easy to calculate a missing quantity if you know the other two of them. Now the units of resistance are the ohm, and they're represented by the Greek letter capital omega. And so you can see over here the capital omega is the symbol for the ohm. And it turns out that the units of ohms are set such that 1 volt is equal to 1 amp times 1 ohm. And that, again, things are designed there to be as simple as they can be to make our lives as easy as they can be. You can see in figure 7, this is the symbol for a resistor. It's just, several diagonal lines. And those diagonal lines, I tried to draw them so that there are 3 peaks on the top and 3 peaks on the bottom. It's not a really big deal, but if you draw them with only 1 or 2 peaks, people might not be certain that they're resistors. If you draw them with 6 or 7 peaks, that's just going to take you longer than they need to be. Notice that on this symbol for this resistor, we've indicated not only the voltage, along with the polarity with plus and minus symbols, we've also included information about the current, including the direction. Not only do you have to label the direction of the current, but you have to label the polarity of the voltage as well. Every time that I draw a resistor, if I'm going to put a voltage or a current on it, I'm always careful to include the polarity symbols or the direction of the current symbols. Now, you might ask yourself, how can we calculate the resistance? Well, the resistance really depends on the shape, the size, and the material that's used to compose the resistor. And there are equations that we can study to calculate those resistances. You can imagine that a larger cross-sectional area would be easier to flow through, just like a large pipe could carry more water, and so therefore the resistance would be lower. A longer resistor would be higher resistance, just as a longer pipe or a longer hose would take more force to push the fluid through. And then there are different types of materials that have what are called different resistivities, and those resistivities also impact the flow of the flow of current. Just as if you think of water flowing through a river, if it's flowing through rapids, then the water is going to flow more slowly because it has to overcome all of those stones. But if it's flowing through a nice smooth path, then there's going to be a good, nice solid flow of water.